We're going to start our factoring review by answering the question, how do I know I'm supposed to factor a polynomial or equation to solve it or not? And the best way of answering that question is by starting with what we call a linear equation, something like this, 3x plus 12 equals 48. And what I'm looking for is my variable's exponent. And if the largest exponent is 1, like in this case, even though we don't see the 1, it's implied to be there. If the largest exponent is 1, we know that it's a linear equation, and I'm going to solve it as such. So this is not an example of factoring. It's an example of a linear equation, and we should know how to solve that as such, x equals 12. Now, that begs the question, what type of problem is going to need to be solved by factoring? Well, if we look at another problem, notice the difference already. The variable x has an exponent of 2. And so this is what we call a quadratic. And if we have a quadratic, aka the largest variable's exponent, the largest exponent to our variable is 2, then we're going to solve that by factoring. And there's a variety of different ways to factor. And we'll get into all those different ways here in just a moment. But just really quickly, I'll go ahead and factor that into x minus 4x plus 3. And we'll move along into some more examples. So as we take a look at these next two examples, notice that in both examples, we have an exponent of 2, and that is our largest exponent. In the first example, I want you to take a look at a couple key things. In our two terms, 6x squared and 24x, you notice that 6 and 24 share a common factor. The common factors they share are 2, 3, and 6, the greatest of which is 6. So we call this a greatest common factor problem. And then if I look at my two terms in the variables attached, x squared and x, the greatest common factor between x squared and x is, of course, x. And so to factor this, I'm going to pull out that greatest common factor of 6x, and then I'm going to get some parentheses started. What goes in parentheses? Well, we have to take the two terms and divide them both by that greatest common factor of 6x. And when I do so, we notice in my first term, the 6's cancel. X squared over x is simply going to be x, and that's what I put inside my parentheses. We're going to bring down that negative sign. And then in my second term, 24 divided by 6 is, of course, 4, and the x's cancel, and we end up with 6x times the quantity x minus 4 as our solution, or the factor of that problem. In this next term problem, you'll notice it's a little bit different. And what you should be able to recognize is that both terms, x squared and 64, are what we call perfect squares. In other words, x times x, or x times itself, is x squared. And 8 times 8, or 8 squared, is 64. So this problem is a difference of squares, and we set this up by getting two sets of parentheses, and we're going to take the square root of x squared, which is x, and put it in front, and the square root of 64, which is 8, and put it as our last terms, and then we are going to either go plus minus, as I did, or you could actually put minus plus. It'll give us the same thing. And the reason this works is because when we go backwards and we go ahead and multiply through, x times x is x squared, minus 8x plus 8x is going to go ahead and cancel out, so we no longer have a middle term, and then 8 times negative 8 is negative 64, and we get back to what we started with. We know we have factored that correctly. As we move forward here, you can see both of these examples have 3 terms in them, and you always do want to look for a greatest common factor. Even if there's 3 terms, you still want to do that first in every problem. However, in our first example, let's focus on x squared plus 8x plus 15. There is no greatest common factor. That being the case, we're going to factor this as a quadratic, meaning we're going to get 2 sets of parentheses, and we're going to focus in on a couple things. First off, we're going to focus in on this x squared term. The only factors of x squared happen to be x and x, so we're going to get that right off the bat. 15 has factors of 1 and 15 and 3 and 5. Those are my only factors of 15. In other words, when I say factors, what numbers multiply to give me 15? So in this case, we are looking for either set of these factors to add or subtract to give us this middle term of positive 8x. Now in this case, we know 1 plus 15 is 16. That's not going to work. However, 3 plus 5 is exactly what we need, 8x. So I'm going to put my 5 and my 3 as my last terms, and I'm going to put positive, positive. Now the reason I put two positives is because we know that 5 times 3 is 15, positive 15, which is what we need to get back to what we had in our original problem. And then, of course, when I continue through and multiply, x times 3 is 3x, 5 times x is 5x, both positive, 3x plus 5x, again, gives me my middle term of 8x, and I know I have factored this correctly. Notice the signs in my second problem. I have a positive 21 at the end, but I have a negative number in the middle. So the process is somewhat similar. I'm going to get both sets of parentheses going with x and x. Why? Because x squared is only factors are x and x. However, with a positive number at the end and a negative number in the middle, I know that my signs have to be minus and minus. Why? Because a negative times a negative is a positive, which we need at the end, and then if we add two negative numbers together, we get a larger negative number. So the question I'm asking myself, what are the factors of 21 that add up to 10? Of course, 1 and 21 adds up to 22. 3 and 7 add up to 10, and that's what we need. 3 and 7. And again, you can always check your answers by going through and multiplying. X times x gives me my x squared. Negative 7x minus 3x is going to give us our middle term, negative 10x. So we're 2 for 2. And then, of course, the last terms, negative 3 and negative 7 multiply to give us positive 21. And again, we know we are correct when we multiply to get back to where we started. You will notice these next two examples are pretty similar to the last two. However, notice the signs are different. We have a plus minus in our first example and a minus minus in our second example. And so when we factor this first example, again, we're going to start with getting our parentheses and putting an x in front in both. Again, the only factors of x squared are x and x. However, now we are trying to find factors of 10 that add up to 3. However, since the 10 is negative, one of our factors has to be positive and the other has to be negative. In other words, we could have positive 10 and negative 1, or we could have negative 10 and positive 1. So it gets a little bit more complicated in that regard. Now, 10 minus 1 is 9, negative 10 plus 1 is negative 9, neither of which is the middle term of 3x. So we know those factors are not correct. What are the other factors of 10? Well, 2 and 5. The question is it going to be positive 2, negative 5, or negative 2, positive 5? And that all depends on this sign that I'm circling in blue. It's a plus 3x. Therefore, the larger of these two numbers, 2 and 5, has to be positive. So in this case, 5 is clearly larger than 2, so we're going to have plus 2 minus 5. And I'll leave you to check that answer. In my next example, similar process. Parentheses, x and x, what factors of 20 add up to 8? Hopefully you are going to be pretty good with your mental math, and you can kind of picture in your mind that 10 and 2 can some way add up to 8, and they multiply to 20. Which is going to be the negative and positive? Well, since it's a negative 8 in the middle, the 10 has to be negative and the 2 has to be positive. Quick check, we get x squared plus 2x minus 10x minus 20, and of course when I add those two like terms together, we get a negative 8x in the middle, and we have exactly what we started with. We are correct. Now we are moving on to solving equations by factoring. The number one thing that you have to remember, and this is really important, you must make sure that before you do anything, you always set your equation equal to 0. Now, in this first example, 15x squared minus 10x equals 0, that has already been done for us. We don't have to do any work to set our equation equal to 0, but it is the most important part of solving by factoring. You must set one side of the equation equal to 0. Generally speaking, we set the right side equal to 0. You can do it either way. but that is really, really important. Now, once you've done that, you must then recognize what type of factoring problem it is. And how do I know it's a factoring problem to begin with? X squared. Remember what I said at the beginning of the video. Anytime your largest exponent is a 2, you are going to solve by factoring. Now, in this particular example, hopefully you note 15 and 10 have a common factor. That common factor is 5. X squared and x, they have a common factor of x. And once I've established that common factor, remember I pull it out and then divide both the 15x squared and 10x by that 5x, and you're going to see we end up with 3x minus 2 inside our parentheses, and that is, of course, equal to 0. Now, we're not done. We want to solve this equation. So to solve, one thing I noticed a lot of people forget to do is take this first term that we had pulled out, the 5x, and we are going to set that equal to 0. We are also going to set the 3x minus 2 equal to 0, and these are now linear equations that we can solve fairly easily, I hope. In the first equation, we're going to divide both sides by 5, and of course, x is equal to 0. And in the second equation, we're going to add 2 to both sides. 3x is equal to 2, divide by 3, and our second answer, x equals 2/3. Now, have I done this question correctly? Well, we can check to see if we are right. So when I plug 0 back into my original equation, I get 15 times 0 squared, which is 0. So 15 times 0 is, of course, 0, minus 10 times 0, which is, of course, 0. 0 minus 0 equals 0, and we have, in fact, done the first part correctly. How about checking the answer of 2/3? This one's a little bit more challenging. 15 times 2/3 squared. 2/3 squared is going to be 4/9. So 15 times 4/9 minus 10 times 2/3. Is that going to equal 0? Well, let's find out. If I take 15 times 4/9, that's going to have a reduction here. 15 is 5 times 3, 9 is 3 times 3, and of course the 3's cancel, and I get 5 times 4, or 20/3, is my new fraction. Minus 10 times 2 is, of course, 20/3. And, of course, we know 20/3 minus 20/3 is, of course, 0, and we have done both correctly. On to my second example, which you cannot see quite as well right now, but I'm going to highlight this in red. X squared equals 81. Remember, the most important thing to do when solving by factoring is to set one side, either the left or right side, equal to 0. In this case, I'm going to subtract 81 from both sides, and I get x squared minus 81 equals 0. Again, we know it's a factoring problem because it's an x squared term, and the second part is recognizing what type of factoring problem is this? Well, hopefully you realize x squared and 81 are both perfect squares, and we're going to factor by taking the square root of x squared and the square root of 81 and putting our plus minus signs. This is our difference of squares example. Now, the final answer is found by taking x plus 9, setting it equal to 0, x minus 9, setting it equal to 0, solving these linear equations. X equals in both negative 9, and when I solve the second equation, x also equals positive 9. My two solutions. I'm going to work rather quickly through this next problem. X squared minus 2x equals 24. Again, subtract 24 from both sides to start, and I get x squared minus 2x minus 24 equals 0. And then when I factor this, what factors of 24 add up to 2? How about 6 and 4? Which one's positive and which one's negative? Of course, the 6 has to be negative because 6 is larger than 4, and my middle term is, of course, negative. So x minus 6 times x plus 4 equals 0, and I'm going to set x minus 6 equal to 0, x plus 4 equal to 0, and we realize that the solutions are 6 or negative 4. This next example is a little bit more challenging because you'll notice our term 2x squared is different than what we've been seeing. There is a 2 in front of the x squared. So the process is very similar, but a little bit different. We have to ask ourselves, what are the factors of 2x squared? In other words, what multiplies to give us 2x squared? And there's only one possibility without using fractions. 2x times x gives us 2x squared. So now, the reason this is a little bit more complicated is we have a last term of 3, and of course the good news is the only factors of 3 are 3 and 1, but I'm also going to write down 1 and 3 as well, because we can use combinations here to solve this. In other words, the factors of 3 are 3 and 1, or 1 and 3. We have to figure out which of those two combinations is correct. And I'm going to add in the plus signs, because above we see that we have 2 plus signs. And I'm going to check this by taking a look at the outer terms in our example. In other words, 2x times 1 is 2x, 3 times x is 3x, 2x and 3x adds up to 5x. That's not big enough. We need in the middle 7x, so that is incorrect. If I check my second example, 2x times 3 gives us 6x, 1 times x gives us x, and when I add these together, I get the middle term I desire, 7x. That is going to be my correct answer. I'm not done yet, because remember, I'm solving an equation. I have to take both the 2x plus 1, set it equal to 0 and solve, and the x plus 3, set it equal to 0 and solve. And when I do so, my first equation, 2x is going to equal negative 1 divided by 2. And my first solution is negative 1/2. My second solution is a little bit easier to figure out. It is negative 3. When doing factoring problems, it's really important that your basic skills of arithmetic are very strong. In other words, the better you are at doing mental math, the better you will be at factoring. And the more you practice, the better you should become. When I look at an example like 9x squared plus 6x plus 1, some of you may think that's a little bit overwhelming because of the 9x squared at the beginning. However, if we think and use a little bit of logic, the factors of 9x and x really aren't going to make a whole lot of sense to use in this problem, because when I'm trying to get a middle term of 6x, 9 is already larger than 6. It wouldn't make sense to even try that. So, as an experienced factoring person, I wouldn't even think about doing that. You might. What I should do is look at the other factors of 9x squared, which happens to be 3x and 3x. And the good news is the only factors of 1 are 1 and 1. I know my signage has to be plus plus. And when I check the work here, my middle terms, 3x, 3x, that is going to add up to what we need, 6x. So in this particular case, we have 3x plus 1 equals 0 twice. I'm going to subtract 1. 3x equals negative 1. And we actually get the same solution twice. X equals negative 1/3. And I really don't need to write that twice. Our final example, hopefully you notice x squared minus 32 equals negative 4x. Hopefully the first thing you notice is that we haven't zeroed out one side of our equation. So I'm going to start by adding 4x to both sides. And it's very important to put the terms in correct order. We want our x squared term first, and then we want our x term, and then we want our constant term of 32, negative 32, last, and we're going to, of course, have that set equal to 0. So now I'm able to factor this problem. And when I take a look and factor this, again, this one shouldn't be all that difficult, I hope. We're looking for the factors of 32 that add up to 4, and of course I should also realize I'm going to have 1 plus and 1 minus term. And of course, what are the factors of 32 that add up to 4? How about positive 8 and negative 4? And of course, it's a simple check. There's negative 4x, here's positive 8x, those add up to positive 4x. And of course, 8 times negative 4 is negative 32. And I'm ready to solve. Again, to solve, I take my x plus 8 terms, set it equal to 0. X minus 4 is equal to 0. Solve both, and I get negative 8 and positive 4, which I'm going to put in brackets.